Okay, so before we start the class, this is for me to make sure that I don't forget about it. I should have had the quiz in this class, and for that I had to declare that ahead of time. I didn't do that. So our first quiz will be in the next class, that's February 26th. And the syllabus is chapter 1 and chapter 2 from your first chapter. It's going to be a very simple MCQ and fill in the blanks type of quiz. There will be possibly 10 questions and you get 10 minutes to answer them. Is this clear? Yes. This is for the lab part. We'll have quizzes from the textbook in the lab course. Now for today's class, we'll be continuing with something that we started in our theory part. And I have pushed the code that we have written in our classroom 1002. We were talking about a bank account scenario. So let me open the project. That's our bank account demo, and that's what you'd be working with today. So what we did in there is we created bank accounts, a very generic bank account type. Let me close the other ones. Okay, so for those of you who are not there, see, we have created this bank account type with account ID, account name, address, and balance. And I think we also have the diagram, the EML class diagram right here in this project. So if you download the source code, you'd also find in this bank account demo, this folder, you'd find this bank account dia file, which you can open with dia. So you can see that we have this bank account data type, where we got these private members, account ID, account name, address, and balance. And we allow for the get method for all these things, but only the address can be changed with a set method. So we have written code accordingly. This bank account is already implemented. In addition to that, we have a current account. It's written over here, and there is another file. Let me open that up over here. I left some notes. So here are the rules that for current account, I talked about this thing, that current account is meant for regular transactions. You won't be keeping your money in the bank regularly. You'll be taking it out as you need, as much as you need. So the bank doesn't get to invest your money. That's why they will somehow penalize you or make sure that you don't withdraw that much. So here's a bit of penalty right there, a service charge. That every time you withdraw money, you will lose 15 taka. That will be deducted as service charge. So what I want you to notice, from the general bank account, if you go to the current bank account, there's very little difference in between these two things. So I have written two classes. There is this bank account class, and we also have a current account class. Okay. There is virtually no difference right here. They have the same set of attributes. The constructor even looks exactly the same with a different name, of course. It's just the withdraw method that is a little bit different over here. So if you compare these two withdraw methods, what happens for the current account is that you're deducting 15 taka addition. Over here, this is the only difference that we have. Okay? Compared to the bank account. Because the idea of withdraw is that your balance will go down by a specific amount. And that's what's happening for both the general bank account and the current account. It's just that for the current account over here, you're going to lose 15 taka extra. So you have to have that amount in your bank before you withdraw. So this is what's going to happen. Now, this is something we have done in class already. The deposit method, the withdraw method, the print, and all these get and set methods, they're all written, okay, for both the current account and also the generic bank account task. In today's class, lab exercise, this is where I'm going to give you some additional tasks. So if you look at this project, this bank account demo project, if you run this project, you'd see that there are 3 different bank accounts opened. 2 of them are general bank account and 1 of them is a current bank account. On all 3 accounts, we deposit some money, we withdraw some money, and then later on we print them out, B1.print, B2.print, and B3.print. What you notice is that for current account, when we deposit money and when we withdraw money, we actually use 15 taka extra. That's what comes up over here. So that's with the current account. So what I want you to do is I will give you description or some specific rules about other bank accounts, and your task would be to create new data types. Just as I have created this current account from the bank account, your task would be to create new bank account with some specific rules. Is this thing clear? So for current account, let's say I have written the rule right here that says that for every withdrawal, this is already done, for every withdrawal the account holder needs to pay 15 taka extra. That's the rule. Okay. So now if we go for another account, and let me write them down. Let's say this is already done. Let's say for savings account, okay. The idea for savings account is that you're not going to withdraw that much, and it's mainly meant for saving. And in order to encourage that people deposit more and more money, you'll give them a little bit of incentive that every time you deposit money, whatever you deposit, you'll get 0.05% bonus on top of that. Okay. So if I'm going to deposit 100 taka, how much do I get in my bank account? Let's say 100.05, because this is for percent, right? So for every 100 taka, this is the extra bonus that you get. It's a very small amount, but this is what's going to be added for every deposit. Okay. Let's say we have another rule. For every withdrawal below 1,000 taka, there will be no service charge. However, for withdrawals above So we really want to discourage withdrawal from the savings account, and what we are saying, I mean, this is just a hypothetical bank account scenario. This doesn't exist in real world, but we are saying that every time you withdraw money, if it's less than 1,000 taka, you don't have to pay the service charge. But if you withdraw more than that, then there will be 1.5% service charge imposed. So let's make it more interesting on the additional amount. So just to make it clear, let's say I'm going to withdraw 2,000 taka from my savings account. Then what's going to happen is that 1,000 taka is free. I can withdraw that. But above that, like the additional 1,000 taka I'm withdrawing, I have to pay 1.5% service charge on the additional amount. Okay. So what you need to do now is you need to create a new data type for the savings account, and in that case you have to modify both the deposit method and the withdrawal method. Is this thing clear? Okay, so what I want you to do is not just the savings account. I want you to create two different bank account types. One is the savings account and the other one is the credit card. Every transaction, the purchases are like withdrawal, Okay, so just these two things, the savings account and the credit card. These are the two data types you have to create. What I've already done for you is I have created the general bank account data type. I've also created the current account thing. This is already done, and you need to write these two things. You have to create a savings account data type. You have to create a credit card data type, and you do that in this project. You have to download the code. It's already uploaded in our Bitbucket repository. You have the link in your Google Classroom, so you can download it from there. So additionally, what you have, once you open this project, you'll be creating a separate file for savings account, another one for credit card. Is this part clear? Okay, and once you do that, you'd have to properly test it out. So possibly create some saving account object over here, like savings account B4, maybe create a credit card B5. Okay, create those accounts, do some deposit, do some withdrawal, and see that it's working or not. Okay. Let me explain the credit card scenario. The way we have presented this is that once you create a credit card, you'd have an initial credit limit. It's not the opening balance. When you have a credit card, you don't deposit money to start. Okay, because you're buying with money that's going from bank's pocket. So the idea is that you'd have a credit limit. Let's say I got 1 lakh credit limit on a card. Okay. So I can purchase anything which is worth 1 lakh taka or less. And I can do as many purchases as I want, given that limit. So every transaction or the purchases are like withdrawals. Every time I make a purchase, I'm actually withdrawing money. So my credit limit is actually going to go down. Okay. And if I deposit money, I'm actually paying for all the purchases that I've done. It can be partial payment, it can be a full payment. So if you're using credit card, you probably know that at the end of the month you get a bill that this is the amount you need to pay, and it also says a minimum amount you need to pay. The remaining amount will be charged with interest. But I'm not talking about a complicated scenario like this. What we need to know at any given time that how much we have actually spent, what's due, How much do I have to pay the bank? So we need to figure that out. Okay. Let's say I start with 1 lakh taka as credit limit, and I make a 10,000 taka purchase. Then my credit limit goes down to 90,000 taka. But I also need to know what's the total amount I need to pay the bank back, and the answer to that is 10,000 taka. So there can be an additional method, or you can also use the balance itself to know how much money I owe to the bank. Okay. So the scenario is that we have to rewrite both the deposit and the withdraw method over here, and there will be an additional attribute. This credit card is different from the savings account and the current account because those two accounts, they don't have the credit limit thing. So you need to make changes over here in this diagram. So this is for current account. It has account ID, account name, address, and balance. If you go for credit card, you need these four obviously, but additionally you'd have something else called credit limit. Is the task 3. Okay. So create those two data types, test them out, and show me how everything is working or not. I will have this thing running on the projector, and your task is to do these two things. Okay, so let me mark them. This one and this one, that's what you're going to implement. And I'll pause the video for now. Any question about any of these things? We know how to download the code, right? Okay, let me check. So our source code git is over here. You can take this link and let me open this in a different location. See, what I'm going to do is, here's this thing. The exact code that you need to run is written right here, so you can copy it from here, git clone and everything. So let's say you open up a terminal, ERM, like you open up a terminal like this, and you can just say, let's say, go to my documents folder, for example. Or downloads even. Let's say, let's go to downloads, and then I can paste this link, paste this thing, and it will download everything in there. Okay. Or alternatively, you can close everything over here, close all projects, go into team, git, clone, and if I paste this thing and give it a location where I want to download it at, let's say I want to download it at my desktop, I can give the location, and then it I copied with git clone. Sorry, not that. Just this link. If you just copy the link over here and put it there, you go next. It will download it on my desktop now. Let's click finish. I went from team, git, and clone. So once that's done, you can go and hit open project, and this is where you can open this bank account demo. And that will open just that project. Okay, so that's another way of copying that. So either you can copy from the terminal by copy pasting this command, or you can copy this link and go into your NetBeans and go into team, git, clone, and put it there. Once it's downloaded, you get the option to open a project, and that's when you open the bank account demo project. Okay. So pause the video and I'll be around. Let me know if you face any trouble with anything. Okay, the savings account scenario is really easy to do. I mean, it's very much similar to current account. So let me do the other one though, like this credit card. It's a little bit more difficult. See, what we can do over here, let me close is this? We can open the project that's in our, right here. So we got this current account, and the class that we're going to create will be quite similar to this with a few changes. And in class we started to talk about inheritance, but I didn't show you how to do inheritance yet. That's why I'm not going to do it in the way of inheritance yet. But let me copy this and we will create this new class right in here. And it's going to be our credit card class. So I can pretty much replace everything, and it's not going to work because this is not current account. This is supposed to be credit card. The difference with credit card though is like when we open this thing, we don't have any provision to pass the credit limit, so that needs to be added. So we have an extra parameter to pass. Now initially, when we open up a bank account, we say how much money we are going to open it with. That's why we have this balance. But for credit card, the scenario is actually different. We have a credit limit. That's what we are going to put in. The balance, initial balance will be zero because we haven't made any purchase. As we are purchasing new items, our balance will go down. When we repay the amount, the balance is going to go up. So based on that scenario, we're just going to edit this out and say that we don't need balance, we need credit limit instead. The balance over here is going to be initially zero because there were no purchases yet. The credit limit, however, will be whatever you pass. Something like that. Okay. So when I create a credit card, so B4 equal to new credit card. So this one's for Akibsar, and is somewhere near Bukura. And over here, this is going to be the credit limit, not the balance. So let's say Rakibsa got a credit card worth 50,000 taka as credit limit. So what are the things we can do with this? We can make purchases, we can buy items, right? So let's say those purchases are withdrawals. And they're just going to be something like, let's say I make a 500 taka purchase, I make another 10,000 taka purchase, and now I need to know what's going to be my balance, what's the amount I want to pay to the bank, or I can pay some money back, like I can deposit, let's say 500 taka, so I repay 500 taka. And if we print this out now, our balance would be minus 10,000 taka because that's the amount we owe to the bank. We have to pay this amount back to the bank. Okay. So as it is, it just says that you don't have sufficient balance. You don't have sufficient balance. Every time I try to withdraw something, my balance is initially zero, so it doesn't let me do that. Because in our credit card scenario, if you look at the withdraw method, this is what we have copy-pasted. This is no longer going to work. It is a totally different logic over here, and we need to adjust accordingly. The withdrawal and the deposit, they should work differently. So every time you deposit money, that's going to increase your balance. So in that sense, the deposit method is not too bad. If the amount is greater than zero, we still need that, because we cannot deposit negative amount. If the amount is greater than zero, we are going to increase our balance. However, when we are trying to make a purchase, how do we allow the purchase to go through? How do we know our remaining credit limit? Can you guys tell? Let us consider a particular scenario. Let's say right over here for this credit card, say our current balance is equal to 0. Our credit limit is equal to, let's say, 50,000 taka. Okay, that's the scenario. And then we purchase something that's worth 10,000 taka. What's going to happen now after this purchase? What's going to be the new balance? Minus 10,000 taka. The credit limit is still 50,000 taka, but that doesn't mean that I can buy something worth 50,000 taka. The most that I can buy is worth 40,000 taka. So how do I find this out? This credit limit plus balance. So whatever amount I want to withdraw, that's actually going to be less than or equal to credit limit plus the balance. Is this logic clear? The withdrawal amount cannot be more than that. So we can write this in withdraw that if the amount that you want to purchase is less than or equal to credit limit plus your balance, then this is alright. Okay? And this amount obviously has to be greater than 0, otherwise it doesn't make any sense. Right? If that's the case, then what should you do? Once I make this purchase, my balance goes down. Just like any withdraw operation. Every withdraw operation reduces your amount. So balance would be equal to balance minus amount. Okay? If it's not the case, this is when we return true. If this is not the case, then we can do as we did before for error. You can just say you do not have sufficient balance, so return false. Okay, just like we did before. So what's the real difference over here? With current accounts withdraw method, let me line it up. If you look at these two withdraw methods, over here the logic was if amount plus 15 taka less than equal to balance, that's what we check. But over here we are checking whether the credit limit plus the balance is more than the amount. That's when you allow this, otherwise you don't. So if you run this project right now, you see right now it's not complaining anymore, and it correctly shows that this has minus 10,000 taka balance, which is to say that I have to pay 10,000 taka to the bank because I bought on credit. So for example, in this demonstration, if I make further purchases, like say I made another 20,000 taka purchase, that would mean I have to pay 30,000 taka back. Okay, and after doing that 20,000 taka purchase, if I try to make another 20,000 taka purchase, would I be able to do that? The credit limit, how much was it? 50,000 taka. So will this work or will not work? This scenario, whatever we got. It will work. What is the total amount we are withdrawing right now? 50,000 taka, 50,500 taka. But what's the credit limit? 50,000 taka. So we are trying to withdraw more than what we have. So in that way, yeah, it doesn't work. That particular transaction right here, this would fail because we don't have the sufficient balance. Whereas if we paid this 500 taka before purchasing that 20,000 taka item, this should work. Right now, I have to pay a total of 50,000 taka back to the bank, and that's what it was. Okay, but if if I make more purchases than what my credit limit allows, that's not going to work. So it's going to stop right here. This is what I wanted you to try, to create a new data type where we have such features. It works like a credit card, that we have a certain credit limit, we can make purchases, and we can also pay back the amount at the end of the month. Yes, we don't have any such thing for interest calculation. That needs to be in place, but other than that, this is an example of how a credit card may work. But more importantly, what we're learning in doing all these things is how to create our custom data type from a given idea. And once we have that in place, what we will cover in our theory class, not in this lab class, is how we can reduce the amount of code that we are writing. Like over here, all these things will be reduced to very few lines of code, like 2 or 3 lines of code per class. We won't have to write much, because we'd be copy pasting stuff from here. I mean, right now we are copy pasting, and that's why the classes are big. And when we go there, we'll see that we'll be reusing code that we don't even have to write. We'll just say that we extend from this. We're going to make a total reuse of all these things, and the things that change, only those parts we will write down. So for the credit card, for example, we'd write this part, because those are the things that change. However, the print method, the get methods, and everything else, we don't have to write any of that. So right now it's like a 73 lines of code for this class. It will be reduced by a big margin for this one and also for this one. That's something we'll figure out in our next class. So if you have done the savings account thing already, then that's good. If not, please try to do that at home. And in our next class, when is our next class? Today is Monday. Next class is on Thursday, right? So we'll cover that on Thursday. Thursday, yeah, 22nd. It's not a problem. Any question about any of these things? Okay. So if that's the case, I'm going to save this journal and the code, and I'll upload the latest changes and also upload the video. Please make sure you come prepared for the quiz. We will have 5 such quizzes, so it's going to be like every lab class from now on you'll have one quiz, a very tiny quiz, like a 10-minute quiz, but we will have such quiz. And they will all be announced. I'll give you 1 or 2 chapters to read for the text.